Hello statistics students, my name is Jami Emigh, and this video is discussing chapter 3, title Describing, Exploring, and Comparing Data. Section 3.1 is on different measures of center. All right, once you got your titles down, I would like to ask you to take out a blank sheet of paper. And what we're going to do with that sheet of paper is create a reference sheet of statistics symbols. Trust me on this, okay? This language has a lot of Greek letters as well as variables, and you don't want to fall behind on what each of those variables or Greek letters represents. So having a reference sheet, you're going to need one reference sheet. It'll last the entire semester. The good news about these symbols in statistics is once they're assigned, most of them, once they're assigned, like for example, lowercase n, that is the symbol used to represent the sample size. And unlike in an algebra class where like in the next question, lowercase n could mean something else, in statistics, it won't. Lowercase n will stay the variable that we use for sample size for the entire semester. So this reference sheet, you're gonna use it often, especially when you're first learning these. So you want it to be somewhere that you can quickly refer to it. I promise it'll make your life so much easier, okay? All right, so hopefully you've got a blank sheet of paper out right now and you've titled it Reference Sheet of Statistics Symbols. All right, the first symbols we are going to write on the reference sheet are this one here. This is the Greek capital letter sigma, and that is always going to represent the sum of a set of values. So if you take a set of values and you add them all up, okay, that's what sum represents. What you have done is calculated sigma. Next variable, x. This is the variable used to represent each of the individual data values. So all of those values that you added up, if we're just interested in one of them, we would call that one x. Lowercase n, like I was talking about, that will always represent our sample size. We know sample's smaller than the full population. The sample's a subset. So lowercase n, in the what about carbon monoxide detectors, lowercase n was equal to 30, and the population was 38 million. Capital N is used to represent the population size. So in the carbon monoxide detector example, capital N would have equaled 38 million, lowercase n would have equaled the 30 carbon monoxide detectors that we sampled and tested. X bar, it looks like an X with the bar over the top, and it's read X bar, and it's always going to represent the sample mean. So if you take all of your data values and you calculate their mean, you have calculated what's called X bar. Calculating the mean, most of us first learned how to calculate what's called the arithmetic mean, or we call it the average. So to find the average, or the sample mean, should it be an arithmetic mean, you add up all your data values and then you divide by however many of them you added up. Next one for our reference sheet is mu. It is the lowercase Greek letter mu. It looks like this here. If you change your font, it can look slightly different. Or if you see one person write the letter mu versus someone else, it might look slightly different. But overall, it should look approximately like this here. It is read mu, M-U. It kind of looks like a U, if that helps. And what that is going to represent is the population mean. So you add up all the data values from your population and you divide by your entire population size. All right, so we've got that reference sheet started with our first 6 statistic symbols. Keep that close by so we can use it. All right, let's start talking about the measure of center. And we're also going to add these to that reference sheet, okay? So have that reference sheet by you. We'll be adding stuff and using it as we go. Arithmetic mean, like I said, it's often called the average. That can be found given, for example here, the Verizon data speed times in megabits per second. So our data speed times given to us are 38.5, 55.6, 22.4, 14.1, 23.1. How many is that? That's 1, 2, 3, 4, 5 of them. So we are requested to find the mean. To find the mean, we will add up all of our data values and divide by the number of values that we added up. It looks like this. X bar, that's our stat symbol for mean, is equivalent to sigma, that is our symbol for the summation. So add them all up, all the x's, these are all of our data values, and then we'll divide by lowercase n is our sample size. We have 1, 2, 3, 4, 5. All right, let's do it. We will add up all of our data values. After adding them all up, we'll divide by 5, and we'll get 30.74 as our average megabits per second, or the arithmetic mean megabits per second, based on this sample of 5 Verizon data speed times. If you're having trouble typing this in your calculator, if you're getting a different result, it might be the order of operations. You have to make sure to do all of the addition, so get your numerator sum. Then after you have that sum, divide by 5. So keep trying it until you get to 30.74. If you're having trouble, like I said, it's probably the order of operations. Another measure of center is called the median. Think of it as the middle. So the median is found by taking all your data values. So here we're given 1, 2, 3, 4, 5, 6, and find which one is in the middle. It's the median. To do that, to find the middle, we have to line them up in order. So we sort them in order like we have here, and then we find which one is in the middle, literally, like a location, the middle. Well, I'm just thinking, I'm starting to eliminate, if I'm starting to eliminate from each side until I find the middle, I would get 1 and 1, okay? Getting closer to the middle. Here and here, getting closer to the middle. Here and here. Oh, turns out that the middle is right here. But there is no data value there, so there is no middle data value. That's because we have an even number of data values. So if there isn't one right in the middle, it's okay. We're going to find what is halfway between 0.73 and 1.10. So we're going to find the middle of these two values, which we do by adding them up and then divide by 2. So it turns out that the median, or middle number, is 0.915. Okay, the most, or called the mode, that is another measure of center. So it's our third one. We've got mean, median, and mode. I like to think of them as average, middle, and most. They're all ways to measure the center. All right, so for the mode, it's the most frequently represented data value. So here in part A, the 5.4 is represented once. I don't see it any more times. So frequency on the 5.4 is just once. I see the 1.10. Oh, I see this twice. So far that one's represented the most times. 0.42 once, 0.73 once, and 0.48 once. Okay, so the 1.10 is represented the most frequently. So that makes our mode 1.10. Try B and C. Pause the video and try B and C. Go ahead. Welcome back. If you found that the 27 and the 55 are each represented the most frequently because there are 3 27s and 3 55s, you're right. So we have 2 modes here, and that's okay, the 27 and the 55. We call that bimodal for 2 modes. 2 data values were represented with the highest frequency. Now, if you were struggling with part C a little bit, it might be that you found no answer. And you know what? That's okay. There can be no mode. Here, each of these values is represented just one time. All their frequency is represented once. So there is no data value that is represented the most frequently. And that's fine too. You can have no mode. So you can have a mode. It can be bimodal. You can have no mode at all. All right. Another thing that we're often asked to calculate is called the range. The range of our data values is the maximum, so the largest data value, less the minimum data value, as well as the mid-range, which is the maximum value, so the largest one. We add this time the minimum value, and after we do that addition, we divide by 2. And that helps us find what's called the mid-range, the middle of the range. Okay, make sure you have those 2 formulas written down on your reference sheet. All right, what we're going to do now is look at an example, and I'm going to show you how to use technology to calculate the mean, the median, the mode, instead of doing it by hand like we just did. Ready? So we're going to use a spreadsheet program called StatCrunch. You all have StatCrunch. When you purchased access to MyLab and Mastering, that's the Pearson product, you got access to StatCrunch. This is what we use in this class instead of tables and charts or graphing calculators. We use a spreadsheet called StatCrunch. And if you're ever asked to find the mean, the median, the mode, I'm sorry, I skipped one. The mean, the mid-range, the median, the mode. Here are the step-by-step instructions on how to do so. Step 1, click the little blue rectangle icon located near the top right of your data. Click Open in StatCrunch. Open the Stat drop-down menu, open Summary Stats, select Columns. Select your column by clicking on its name. So I'm going fast because I'm going to show you how to do this through an example. If you need the mode, we have some additional directions, and we're going to hit compute. Should we be asked to calculate the mid-range, we will do that by taking the max plus the min and dividing that result by 2. All right, let's try it. Here's an example, and we're asked to find the mean, the median, the mode, so 3 measures of center, as well as the mid-range, middle of the range of the given data. Okay, so our data is 7, 24, 11, 16, 1, 28, 27, 3, 22, 7, 22, 11, 4, 3, 7, and 0. Okay, this is called the raw data, all right? It doesn't matter that it's given to us in 4 rows like this. There are no titles on these rows, so this is just a list of values. So step 1 says to click on the little blue rectangle icon located near the top right of your data. All right, so I put a little fake one right here. When you get to a homework question, there will be a little icon right there. It looks like this, and you'll click on it. When you click on it, it's going to open this data into your spreadsheet, which will look like this. Will open, and you'll see that your data is already loaded into the first column for you. It didn't have a title, so it's just called VAR1, so that's just something to make a mental note of. And here is all of our quantitative data. Okay, look at your notes. What did it say to do next? Stat drop-down menu, so that's right here. Look at your notes. What does it say to do next? Summary stats. Look at your notes. What does it say to do next? Click on columns. I know you're just watching me for now. You'll have a chance to practice, but just watching me for now. Click on columns. Look at your notes. What does it say to do next? It says select your column by clicking on its name. So ours, like I said before, it didn't have a title, so it's just called var1. So we have to actually click on that. This step can be easy to miss. You got to click right here. Boom. Notice that it populated over here. That's what we need. Look at your notes. What does it say to do next? It's asking you if you need the mode. And if it says if you do need the mode, then, which we do, we are requested to find the mode, then we need to go to this right here where it says statistics. And these are all of the things that this program can calculate for us. It's a lot. This one program can once we input our data, it will output sample size, mean, variance, standard deviation, standard error, median, range, minimum, maximum, quartile 1, quartile 3 for box plots, the sum, the interquartile range, IQR, unadjusted variance, standard deviation, a lot of stuff that it'll calculate. Notice here at the very bottom is mode. Okay, so the ones that are default selected are over here. Okay, these are all the options in the shaded in part, and this is what we have selected. So this one defaults to select sample size, mean, variance, standard deviation, standard error, but it doesn't make it all the way down to the mode. It stops at quartile 3. So if you need the mode, no problem. We're going to click on, look at your notes, it says it. Click on N. I use a Mac, so at this point I hit Shift and then my down arrow. I hold my down arrow. Now mode is selected, and you can see it's over here now in my selection. And then look at your notes. What does it say to do? Compute. After I hit compute, this right here is called the output screen. So we input this data. We asked StatCrunch to run a program for us. That program's name was Summary Stats Columns. It ran the program for us, and this right here is called the output screen. Okay, inputs, program name that runs, output. All right, and what this program outputted for us, lots of stuff. So we just need to provide what was requested of us. What did it want first? I believe it said it asked us for the mean first. Here it is, 14.5625 right here. Hope you can see my cursor. Oh, here we go, mean right there. Okay. Next thing it wanted from us was the median, I believe. Median. That's right here, 11. Next thing it asked for was the mode. It's at the very end. Mode, right there is 7. And then the last thing that this example requested from us is the mid-range. And so if you're looking for mid-range, there's median, there's range, but I don't see mid-range. No problem at all, because we know that the mid-range is just the maximum, so the 44. Then we'll do the plus sign, the 0, and then we'll divide that by 2. All right, let me shrink this down and show you how to write up your answers. So here we've got data was open in StatCrunch. We found that the mean, 14.5625. We found the median was 11. We found the mode was 7. And we found that for the mid-range, we needed to use the output screen, max of 44, plus the minimum of 0, dividing that result by 2, and that gives us a mid-range. The middle of the range is the value 22. All right, notice that these are all exact values. For the mean, we took the 14.5625. We gave it everything that the output screen gave us. Had the directions said round to the nearest whole number, then we would have gone with the number 15 right here. Had it said round to the nearest tenth, we would have gone with 14.6. But it didn't. If the directions do not request you to round or give an approximate value, then make sure you don't cut off any decimals. Give everything you can. And that is how we use StatCrunch to find the mean, the mid-range, the median, the mode. And as you saw, that program also calculated quite a number of other things for us. Should you be requested to find them, you can run that program called Summary Stat Columns. Another type of mean is called a weighted mean. That's where each data value could have a different weight on the final outcome. For example, a GPA. Let's use this example of a student's first semester in college. She was taking 5 classes. At the end of the semester, she got an A in a 3-credit class, an A in a 4-credit class, a B in a 3-credit class, C in a 3-credit class, and an F in a 1-credit class, sorry. All right, so this semester, she took a lot, 5 classes. How many units did she take? 3, 4, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so she was taking 14 units this semester. 5 classes, 14 units. So the total weight is the denominator, okay? Adding up all the units, she has 14 total. To find the numerator, we're going to have to add up each of her units multiplied by what letter grade she got. Well, to multiply by a letter grade, we need to give the letter grades points. So we're going to make A's worth 4, B's are 3, C's are 2, D's are 1, and F's are 0. Okay, so what we have for our solution is the number of credits. Those are the weights. We know that that summation of the weights, or the denominator, is 14. And now to find the numerator, we're going to have to pair up, for example, this 3-credit class right here, she got an A in that one. That was this right here. So this right here would be one of our W times X. This right here, this 4, we're going to have to multiply with this 4. We're working on our numerator, W times X. So times, we're going to multiply the 3 times this 3 times this 2, and this 1 times this 0. So that's going to give us all of our W times X's, but then we can see here that we have to add them all up. That's what this capital sigma means. So it'll look like this. The 3 times 4 plus the 4 times 4 plus the 3 times 3 plus the 3 times 2 plus the 1 times 0. So that is going to give us a numerator of 43. We divide that by her total number of units, which we know is 14, giving her a GPA of 3.02. We round those to the nearest 2 decimal places for grade point averages. A weighted mean can also be calculated from a frequency table. In Chapter 2, we constructed this part right here called a frequency table. Okay, so this part should look familiar. All the other stuff here is just to help us calculate the weighted mean from a frequency table. So these are service times in seconds. The first class was between 75 seconds and 124 seconds. 11 of the data values fell in that class. You can see we have 2, 3, 4, 5 classes, and the frequency is actually the weight this time. For example, this second class here, it's going to weigh more on our outcome because 24 data values fell in the second class. compared to the 5th class here. This is going to weigh less because only 2 data values were in that class. Okay, so to do this, we're going to find the middle of each of our classes. So the middle of the first class, you add up the upper and lower bounds, divide by 2, 99.5. Middle of the second class, middle of the third class, midpoint of the 4th class, and midpoint of the 5th class. Then we're going to multiply each of those by their frequency or their weight. So that gives us 11 times our 99.5, 24 times 149.5, our 10 times our 199.5, our 3 times our 249.5, and our 2 times our 299.5. And then we know from the formula that we then have to add all those up, and this right here will be our numerator. For our denominator, we add up all of this column. Whoa, it's a funky looking sigma. And this right here will be our denominator. So the GPA is 1,025 divided by 50, which gives us a service time of 160.5 seconds. And we need to note that that result is approximate because it is based on the use of those class midpoints. We didn't calculate it based on the 50 service times. And that is how we find a weighted mean from a frequency table. That'll end our discussion on section 3.1. My name is Jamie Emigh. I'll see you guys next time when we talk about section 3.2, measures of variation. Have a good day.